Let's move to our next topic, which is association. What is association? Accessing one class properties and functionalities into another class is known as association. This is the same definition we were learning in inheritance, which means there are two ways to access properties and functionalities of one class into another class. One is inheritance and another one is association. So now we are going to learn how we can access properties and functionality of a class into another class using association. Let's see the implementation directly. In this implementation, I have department class having department related information and employee class is having employee related information. And I want to print employee information along with the department information so that I can make more senseful information here. Okay. So for that reason, earlier I was using inheritance and I was directly inheriting department into employee and then I was able to access those properties and functionalities. But now using association, I can directly instantiate department class object in my employee class that you can also do. And once you instantiate department class object in employee class, you can directly call department information, department related methods there, and you will be able to access department properties and functionalities into employee class. So first I'm printing department information and then I'm instantiating employee class object and printing employee information, and then collaboratively I'm printing both of the informations there. So in that way I'm able to print here more senseful data. I am collaboratively printing both of the information. So you have both of the options there. Either you can use inheritance or you can use association. However, we will always prefer association over inheritance in case of accessibility of one class into another class. Inheritance we use most of the time for method overriding. But why we prefer association over inheritance? We are going to learn it in Spring Framework strategy design pattern. There we will learn why association get priority over inheritance. But as of now, there are two things. One is inheritance and second is association. Both are used to access properties and functionalities of a class into another class. Now let's move to our next topic, which is classification of association. We have two type of association. One is known as aggregation and another is known as composition. And it's a very repeatedly asked interview question that what is the difference between aggregation and composition. Okay, guys, always remember that both are the type of associations only. That means in both of the cases you are going to create one class object into another class ultimately. Okay, now we will try to understand their differences. Aggregation is a has a relationship and composition is a part of relationship, which means when we are creating b class object inside a class object in such a way that both class object are completely independent from each other. If a class object will be exist or b class object will be exist without each other as well, then that is known as aggregation. That's a has a relationship because class a is just having class b object reference, right? But composition, which is part of relationship, means you are going to create b class object inside a class object. In that case, if you will lose the reference of a class object, you will not even able to access b class object reference because that's placed inside the a class object, right? So that is a part of relationship and that is known as composition. So aggregation is a kind of association which is a weaker relation, while composition is known as stronger relation, because in aggregation class a object and class b object, both objects are completely independent from each other. Okay, and class a object is not actually owning class b object, while in composition class b is there inside class a object. Class a is composing class b object. That's why that's a strong relation, and you can take the real time examples as well. In companies we have department entity and we have employees entity. Both entities are completely independent. Employee can be there even without department, right? But if you'll see the another example of car and engine, you cannot assume an engine without car. You can have it, but that doesn't make any sense. Engine will always be exist within the car and then only it will make sense. So that is a composition. Let's try to understand aggregation and composition with their implementations and begin with aggregation. I have employee class having employee name and ID and initializing these properties by constructor, and similarly I have department class having department name and list of employees initializing by its constructor again, right? Collections I am using, constructor I am using, don't worry about these concepts. These are going to be covered in upcoming classes. Okay. So as of now, just focus on aggregation only. Here I am holding list of employee objects. I'm not directly holding employee object inside department class. I have a list of employees. In that list, I'm going to add the employee object. And for that reason, I have a method here, add employee. I can pass employee object there, and that employee object I'm going to add into collection. Similarly, I have a show employees method here, which is going to print all the information related to the department and employee, right? Now, in the main class, I have created two employee objects. First, I'm creating with John, and second, I'm creating with name of Alice. And then after I'm creating department object, and then in that department object, I'm start adding employee objects. I first add employee one, then employee two, and then I'm saying show employee to show the employee information. If I simply run this, what it is doing, let me run this. It's just simply printing the employee information with the department information from the department class only, because I'm calling department.show employee, which is the method of department class. As you can see, I'm not directly holding employee object reference inside department. Department is holding the reference of list of employees. Inside that list, I'm adding employee objects here, right? So department is associated with employee, but department is not directly holding employee object reference, and that's why employee objects are completely independent from department. In case if you remove department object, if you make the department reference null, then also employee objects will be exist, and that is what aggregation is. Let's talk about composition implementation. I have engine class which is taking engine type to create engine object. Then I have a car class which is having engine reference declared at class level, which is of instance type, which means that this engine reference is going to take place inside car class object. Now what we are doing in car class constructor, we are passing engine type to instantiate engine class object, and then this engine class object we are passing to class level data member, which is going to place inside car class object. So car class object is composing engine class object. It's a part of relationship. It is an example of composition. Now if you want to create car class object, you have to pass engine type, then internally it is going to create engine object and then instantiate engine object and pass that to car class object reference. And then when you print car class, you will get the car along with the engine information. This is an example of composition. If you lose somehow car class object reference, you will never get access engine reference, because engine reference is inside the car class object. So it's a part of relationship. You will find all theory of association that we discussed here in oops day 2, and if you want to see the implementation, you will find in the same directory here day 2, you will find aggregation, association and composition implementations.